I did a lot of work during my PhD on self-assembling of polymers. So when we came here with Aileen, she started to work on biological molecules, including protein and peptide, and then we started to be interested in how they self-assemble. But then I had also a strong background on hydrogels and on gels in general and their study. And there is where when we discovered that we could form hydrogel out of them. So we started then to work on developing these materials and looking at their gelation. And at the beginning, the interest was in the physics, in the self-assembly, in the materials building. And then with time, more and more interest from co-workers in the materials came up, in particular for people who were working in the biomedical field, in particular in terms of cell culture and tissue engineering. We started to look at the materials property themselves and trying to build materials with controlled property. And I think there really where we made a difference in terms of our work is that we started to understand how to build the materials itself, not just the self-assembly. Peptides seem to be a very good compromise between the biological materials, which are unreliable in terms of their sourcing, quite complex, and synthetic polymers, which tend to be non-biodegradable or which cannot be really metabolized by your body. So this peptide seems to have a very good compromise between the two, meaning that they are natural in their principles, so they can be injected into the bodies. They will be dealt with the bodies without any side effects. But also they are quite simple, which means we can synthesize them using standard chemistry. The main reason then we created a company is to try to get materials which are ready to use, so that people can just take them, do their cell culture work with it, and that's it. And there's no question about formulation, because it can take up to a couple of years to get somebody to learn how to formulate them. So at the moment, we have a family of 5 hydrogel. These are the ones which end up being the most used by our collaborators, and they have all slightly different property depending on what the cells require. Really, the 5 materials we have are a starting point. And then we can, of course, then introduce functionality or design bespoke materials depending on what you're trying to achieve. The materials can be injected, so we can actually make them injectable. We also made them sprayable. Because the materials are based on peptide, which are natural compounds, they're actually non-immunogenic. So we have a lot of work that has shown that they don't create any immune response from the body. They're also biocompatible in the sense that the body can metabolize them. So that's what your body does every day. It gets rid of old protein, etc. The first application for us was people needing 3D scaffold to look at biological questions, such as what do cells do? How do they differentiate? For example, if you use stem cells, there's a very, very strong drive to go from 2D, which is most of the cell culture is done in 2D at the moment, to a 3D environment, which is the natural environment of cells. And a lot of work has shown that actually in 2D and 3D cells do very different things. So there's a very, very strong push to try to get this 3D scaffold. And early solutions are animal-based, and actually they're not suitable for translation in terms of using to humans, etc. So there's a lot of push and drive to try to find synthetic materials which allow you to do these 3D materials for cell cultures. As the materials are taken up, the next application will be them to be used in humans in terms of using them to support therapies. For example, one of the main applications is cell delivery. So at the moment, cell delivery tends to be done with solutions, which means the cells disappear very quickly from the injection site. So using a gel to keep them there is one of the therapies which are sought after. The same way then you can use them to deliver drugs, for example, for tumors, in terms of delivering them localized, so you have less side effect issue around the body. The other very big application that is coming out now is 3D printing. And the 3D printing is really in the context of drug testing. So there's a big push, in particular in Europe, for pharmaceuticals and cosmetic industry to move away from animal testing. So and these materials can be used to create new models.